Hello everyone, welcome to the SIT Research Talk series, which is on broader vision of the visionary outlook on application research. This is Sai Prashant, the student affairs of the Symbiosis Institute of Technology, Hyderabad. This event has been organized by IEEE Symbiosis Institute of Technology, Hyderabad Student Branch, and the Institute Innovation Council. So, without any further delay, let me bring it to you. Today, we are going to have a visionary leader with us, who is Ms. Nita Patel, who will be talking about the visionary outlook on the emerging technologies, which is very much interesting. So, let me quickly introduce about you to Ms. Nita. So, Ms. Nita is the Vice President at the engineering at Otis and Co. She is the 2023 IEEE Commerciality President, and she has even served as what you call the Senior Director of the Engineering at the Otis Elevator and Senior Director of the Engineering at the Healthy Lions Technologies at Greater Boston, and she has a very wide what you call the industry experience during the past several years. Without any further delay, let me give it the floor to Ms. Nita. Ms. Nita, over to you.
Okay, great. Thank you, Prashant, and the team. Nice to join you at the Symbiosis Institute of Technology. Appreciate the work. I'm going to share my screen and talk through a little bit about some of the emerging technologies and some of the thoughts around engineering. How do we move forward, and what does that look like? Can you confirm that you can see my screen and are able to hear me? Okay. Are you able to see the screen? Thank you. Awesome. So just a little bit about the Computer Society. It is a very large technical society within IEEE. I think many of you probably know, but sometimes it's amazing to see actually how big of a society is. There are 157 countries. We have student chapters, over 900 global chapters with close to 400,000 community members. So IEEE has about 450,000 members, and the Computer Society has about more than 60% of those members are in the Computer Society. We have many active standards, over 3,000 events, about 200 conferences, and many peer-reviewed publications. So it's a very large society with a broad global reach. And the Computer Society every year, over the last 7 years, has done a technology predictions. So I'm going to share with you some of the predictions from this past year. We do the work in 24, and then it's published for 2025. And it's made up of a pretty big committee. Dehan Milifujit is our chair. He's in the center, but a pretty broad community of people from all around the world. I'm one of the members of the Technology Predictions Committee, so have participated over, since Dehan started it, to help collect information. And it's always an interesting view of technology overall and what you might want to think about it. So I'm going to share a little bit about that. Concurrently, the Future Directions Committee within IEEE is responsible for a lot of new initiatives. And they also put out a report, and it's called the Megatrends. The Megatrends is like a bigger picture view. And this is also has a very large committee. Dehan also is leading it, but he works very closely with Kathy. I'm a member of this committee as well. So today I'm going to share the view from the technology predictions, which are a little bit closer term, 1 to 5 years, and then the mega trends, which are bigger picture, like 5, 10, 15 years, and talk a little bit about what are some of the things coming up where you might think of, and hopefully I'll have some time, maybe 15, 20 minutes for questions, but feel free to put the questions in the chat as we go through. So what is the difference between a megatrend and a technology prediction? IEEE is very large, and one difference is just which society or which group is responsible. The technology predictions is established within the computer society, so more of our predictions will be more software, high performance computing, AI, more software computing centric. The mega trends is put together by the Future Directions Committee, but they're linked together and they're thinking maybe a little bigger picture. And so you'll see things like power electronics or some of the bigger picture things that may not show up in the computer society. In 2025, when we put together the predictions, there were several categories, so 6 big categories, and then some of these categories are vertical in the sense they go all the way from technology to application, and some of them are more concentrated within a particular area. And so I'll talk a little bit about some of these areas and technologies, but you can kind of get a sense, like in energy, there's around, battery chemistries or nuclear capability, which is making a resurgence, especially with data centers and a lot of the localized power needs that they have in the data centers. One, they need a lot of energy, and 2, they're pretty concentrated. They're facilities and fixed locations. All the way to, very common topics around AI, but what aspects of AI, large language models, LLMs, as well as agents, and then also tools, user interfaces, human interaction. So when you look at this list, you can kind of get a sense it is very computing centric software. Even the energy aspects are around what does it take to do the processing. And then some of the verticals are bigger picture, like advanced or AI-based medical diagnosis, or smart agriculture, which is integration of higher sensors and more automation, more integration of processing and data analytics to be able to get higher yield and smarter crops and better capability within the agriculture. So some of them go all the way from technology to application. Some of them are very technology centric. And I'll walk a little bit through some of what you might see here. So when we look at our predictions, we analyze on a couple of timelines. One, we look at, okay, what would be the impact to humanity? What maturity? So the x-axis on the bottom is the level of maturity of that technology. The y-axis is the impact to humanity. And then the color coding and the size of the circle is it, early all the way to more sophisticated and already commercialized. So when you look at this chart, some things to pull out. The bottom left corner is like low impact on humanities or around space computation. Yeah, today we envision it has a low impact on humanity and probably the least likelihood of success. It's very early, super early. That's why it's very dark green. It's very emerging in the sense of what does it look like, as well as brain computer interfaces. It has currently a low market adoption, and it's very early. On the right side, and the higher you get, is the bigger impact on humanity. Like how might it change our lives, or what can it do to make our lives better? So you see on the top a lot of the medical related, like drug discovery based on AI analytics and, commonization and humanization for DNA sequencing and things like that, or wearables and biometrics. Some of the more mature things which are commercialized, and I'm sure everybody's using them, is around large language models. Then a lot of our tools like Microsoft Copilot or ChatGPT or DeepSeek, right? All of these are based on large language models. And then drones, capability to be able to do autonomous operation in a drone, or autonomous operation in a vehicle, or image-based processing. This has huge commercialization. That means a lot of different companies are already deploying things that allow you to do that and have this capability. So you can see sort of that. In the middle, there's some things like, autonomous driving is not fully commercialized, although it is available. Sustainable computing, especially like with high performance data networks, those types of things. They're looking at what can you do better. Cyber warfare, all of those things are kind of in the middle. They have an impact on humanity. They will change and affect how we live and work. They're kind of mature, but not maybe fully mature to the point of being available commercially. And so this is the set of predictions that the Computer Society came on. Now I'm going to share like megatrends, and then I'll talk about how they kind of connect together. So on the megatrend side, as I mentioned, it's a much bigger, longer term. It usually consists of like multiple technical trends within it. It's a sum of the individuals. We look at a couple of factors: technological, economical, social. It's not a short-term technology or like a fashion, but it's sort of like, where is the world moving? How is it, critical in the sense of broader than the technology, and where do you see it evolve over the next decade or so? And when we look at these technologies and the megatrends, if you think about the three core megatrends, one is digital transformation, the second is sustainability, and the third is artificial general intelligence. And they're affected by these four different factors. One, economical; two, ecological; three, social, political; and then technological. And so the three megatrends affected by the four factors, what does that look like in like real life examples? So let's say you have generative AI, which is a technological advancement that includes everything from large language models to agents to the actual processing algorithms to the data analysis. That is affecting not only the digital transformation and a lot of things that are going to digital trends or agents that do work on behalf of you, but that can also be influenced by it, as well as like search capability, analysis capability, application of thought capability, and even almost new concept creation when you bring different elements together, to ecological factors like rainfall and fires and hurricanes, and how that changes where we focus what we need from a digital transformation. So you'll see, because of some of the weather patterns and some of the higher impact fires and tornadoes and things that have happened, people have changed not only how we create technology, but how we use technology to help us understand. So you have, more advanced warning systems, you have better monitoring, you have auto detection of fire potential, based on camera, satellites, you have better ways to track that. So you can see that it affects all of them, artificial intelligence, sustainability, even COVID and how we dealt with it, not from only a supply chain perspective, but that is truly these social political impacts, and sort of that global view affects where and how things evolve. So these disruptions versus the technology can also have an impact on where and how does technology get developed. So when you think about the mega trends, again, it's sustainability, artificial intelligence, digital transformation, and you look at sort of like then the sort of technology predictions, which is the next box around it, like sort of what are these emerging technologies? In computing, you have things like quantum, cybersecurity, generative AI, cognitive AI, but outside of computing, you have things like energy storage, battery technology, climate change, smart infrastructure, and then the application of that technology in terms of, virtual worlds, self-driving cars, clean, renewable carbonization, all those things. And then they can impact the grand challenges that are coming from those geopolitical, socioeconomic, and this is just a kind of different view from this previous slide of how all those things connect. This is sort of that inside outside circle view of where's the core of the technology and the trends, where they're headed to where the application of the emerging pieces might be. And so then if you take the technology predictions and try to marry them with the megatrends, so this is the same chart I showed you under the technology predictions in terms of like where we thought in terms of the maturity, impact to humanity, and then the circles around each of them show how it fit into the megatrends. So if you look back to, when we were talking about sort of space computing is not going to have as big maybe impact on humanity today, and it's very nascent in its development, it falls under digital transformation. It's a different way, whether we do 3D printing in space to take advantage of like more complex structures because that you're not fighting, gravity, so you can do more sophisticated things in how you manufacture. That's all great, and it will enable a digital transformation, but it's still very early. Two, when you think about, drones, it's also a digital transformation and being able to take things that maybe happened by a human or through human interaction, and you take that knowledge and processing and move it into the digital frame, whether it's for development and design, like test capability, a lot of autonomous vehicles, a lot of manufacturers of systems now do a lot of test and verification in the digital twin, but also from a human perspective, where you can control things more through the automation and through digital techniques versus through human techniques. And then artificial intelligence, of course, in terms of language models and agents. So you can kind of see how the megatrends marry with the technology predictions and where we see a lot of growth. And certainly digital transformation is a big area of growth. Some of it is enabled and fueled by artificial intelligence, but some of it is separate in terms of sensor integration or capability to measure things that didn't exist or that humans can intuitively, but now you're, doing signal processing to enable the sensor to do. So again, another way to think about the overlap between the megatrends and the predictions is to look at, okay, where do these fall in? So the megatrends are around decarbonization, wearable systems, space, and all that is in the middle. And then the technology predictions in terms of satellite recycling or metaverse capability or regenerative agriculture technology, those might be some immediate places where we can see some advancement and growth in the next 5 years. We also did a comparison of like, how do these megatrends match the work that IEEE members are doing, the publications, the conferences. And if you take a look at like IEEE Explorer, it gives you a sense of like, how is the megatrend moving into the research space? So a lot of spike in AI from 2015 to 2019 to today. You can see there was a big jump in the research community, and that speaks to the fact that it is more commercialized, right? When you transition from like low level of publication to more publication, it's because people have found a way to use the concept, and there's faster evolution of the research as well. Digital transformation, sustainability are still on the smaller scale, and maybe they'll have a jump in the next 5-10 years. That's kind of where you can see the potential growth. But these didn't exist in the literature, until 2010. So there's been quite a bit of movement from 2010 to today, to in the last 15 years, to have more and more of visibility application. You can also see it's similar to the patents in the US. A lot of the members are based in the US, and it's easiest to get patent data, but you can see also these three areas have taken a big spike in terms of patents, which are another indicator of application, right? People submit patents when they want to build something with a technology and then sell it. And so you can see that the use of these areas and this kind of capability has really spiked in the last 5-10 years. And so it's another way to see that the trends are moving, what might come out of them in the future. So when you think about all these like technologies, okay, there's a lot of different technologies, a lot of things that are coming up and new, and what do we do with that? How do we think about it? Where do we go with it? We, as a group, came up with some recommendations around industry, academia, government, professional organizations. So for industry, obviously, you're going to focus on the side of commercialization. But what does that look like? And so looking at, how you apply large language models to solving problems for a product or a sustainable future. Factory production is using large language models. I mean, I think everybody is probably familiar with the concept of automated bots to help you answer questions. And obviously, there's a lot of conversation around using the vast storage of information for helping to code better, code faster, do a lot less in terms of customization versus generation. So instead of humans having to generate everything, the AI systems can help us optimize and customize for the application. But that comes with risk as well, and obviously more demand. So the demand in cybersecurity and ethics and things like that have obviously increased as we've made things more automated. So industry has to kind of balance that. They also have to balance the proprietary versus open architectures. Like once you have all of this data and capability to analyze and quickly do things that, as a human, you just can't process that fast. You just don't have that capacity for holding that amount of information and data. Now you've made that data accessible and available. What does that look like from an industry perspective? What truly is your differentiator? How do you keep it sustainable? How do you keep it up to date? How do you keep it, safe if it is something that's proprietary or private, like medical records or, history for individuals? So those are things that as industry finds application, government also has to play a role in thinking about what should be regulated versus not regulated. How do you manage some of these things? So if these technologies are emerging, where do you go with them? And what do you focus on to make open government's looking at standards, government's looking at regulations, government's looking at consistency. But that's also something IEEE as a professional organization can help. You don't want to over-regulate because you want to have a freedom to experiment and be nimble and come up with new ideas. But you need some structure and standards and way of common communications, like Wi-Fi is a very consistent universal standard. Our power grids are standards, our cables and USB plugs, those are standards that have come out of IEEE, but they've come out because a technology has evolved. Industry has found an application to solve, a need for people that they want to use this capability or get benefit from it. Government doesn't want to over-regulate, so then this next best place is standards and to make an agreement in a common way, but without enforcing it as like a rule of law. So those kind of can go into hand in hand. But the other place professional organizations work is with academia to enable access to knowledge, access to, research, and to think about the next challenge. Before you get to adoption by industries, there has to be concepts and ideas. And so the areas where academia can help is in some of the early stage things like the space computing or the brain-computer interfaces, because those are still very new and evolving. There's no clear way of how we are going to use them or what it means. So that's the big opportunity for the research community, and IEEE can bridge that. So IEEE kind of can bridge between government, industry, and academia, but they have kind of different focuses. Academia is sort of what's next, and what are some of those foundational research elements that will enable the next, right? Like somebody had to initially think of being able to use language as a way to think of finding data and solving problems. And then you came up with these models, and then you came up with ChatGPT that's based on the models, and you come up with different ways to connect the dots. So IEEE helps academia in some of that early stage pieces to set the foundation. Government helps to regulate, but IEEE can pick up the other pieces by creating standards versus rules. And then as you propagate into industry, IEEE helps with, understanding of the link between all the pieces. And as a end user developer, maybe like a CTO or CIO in a, chief technology officer, chief information officer, those kinds of things, an investor, where do you want to think about these emerging technologies and capability and where we're going? And again, you'll see it color coded by the mega trends. So as an end user, what does AI mean for you? Well, you certainly have to understand how do you use it? Just like when Word was first introduced, like what is the advantage? When PowerPoint was introduced, Excel was introduced, these are tools. AI is a tool. How do you use it? Do you understand its limitations? If you are doing computation or mathematics in MATLAB or, MathWorks, what does that mean if you get an answer? Let's say you pose the question of trying to compute the orbit around the moon, and you get a rectangular orbit. Like you have to, as a user, say, does that make sense? Does that not make sense? Am I missing something? Did I code it incorrectly? That's the same thing with UI. You have to assess. And so information is accessible, but the knowledge from that information or the conclusion from the information still needs that human. And as a user, you have to understand what are the limits. So maybe you can't add, 5,000 columns as fast as Excel can, but you have to say, okay, if I added 5,000 columns and each had a number 1 in it, but my answer is 200, does that make sense? Like you still have to have that level of thinking through the application of AI. So our job should be get used to it. Try things out, understand where the boundaries are. Maybe you don't understand all the formula and the math and the details behind it, but you should have a sense of being able to reality ground it. In terms of sustainability as an end user, right, we have choice of like how and where do we want sustainability to be included? Digital transformation, similarly, what tools, where is it better to have sensor integration versus not? And then same thing with a developer, like get acquainted with the tools. But as a developer, you also have to understand the logic behind them. Like, what are the logical equations and the formulas that go into making a language model? So, are you designing the language model to search on certain databases, and are you going to make it adaptive and learn, or are you going to make it fixed and just use what information is there? Same thing as you go through, into these different areas as an investor. Where do you want to submit and support and, kind of invest, as well as consider the technology pieces behind it? And then a couple of things as an individual, where might you think about sustaining your skills mix? And so when you think about the mega trends, digital transformation, so understanding analytics, understanding operations and maintenance, and where the use cases are, sustainability, like the end-to-end life cycle of like, okay, if I'm creating something, how will I also maintain it or revise it or revamp it? And it could be everything from a physical piece, like even clothing. Okay, where am I going to source the material? How am I going to build it? What is the factory and the footprint and the power necessary to build this sweater, all the way to how could I eventually recycle it, or does it, easily compost out of this material or so not? But same thing for code. You have to think about, okay, that longevity, is it code that can be sustained? How will it be sustained? What does it require to be sustained? And what is the application when you take capability out of it? And similarly under artificial generative intelligence, like, okay, data scientists, and you can see sort of the trends of where are these trending up with that there's an increase in those skills needs, increase in those jobs, decrease in sort of some of the hands-on maintenance because more things are getting automated. Maybe some, architects are staying kind of stable because you still have to think through a design and an architecture, but it's at a different level. Like if you now have Excel, you're going to figure out how you take data and do analytics on it differently than if you had to do it with pen and paper. So you still have to think of a solution, but your tools that you use for the solution are different. And in terms of the technology predictions, like, okay, what is it impacting in terms of our skills mix and where the careers might be going and what kinds of things to be thinking about, you can see where there has been an increase. So you might look at this and say, okay, why are language models going down? Well, a lot of that research, a lot of the application of it has already been put in place. Not to say there isn't more, but you're not going to see that same big spike like we saw in one of the charts earlier. It's probably going to plateau and sort of level out a bit. So the number of people to do the research, the number of people to do the application of it, it's probably going to stabilize and start trending down in the next 5-10 years versus trending up. So things to think about in terms of these megatrends and technology predictions. So I know I went through a lot of information, but I did want to make sure I had enough time. I have like a little bit more detail on some slides, but I'll stop here and take questions so that there's enough time for us to answer things about technology, about trends, where things might be going.
Thank you so much, Ms. Nita. So, guys, do you have any questions? can post your questions in the chat window.
Yeah, so one question I get sometimes is like, okay, how do I learn about these different skills? I mean, I think many of you probably know you're also students, so you're learning it in your school. But the IEEE Computer Society and the Future Directions team has the technology predictions as well as the megatrends in a report that they publish, but they also give links to different resources where some of the data is and available. So if you go to the IEEE site and search for the technology predictions or megatrends report, you'll get also a listing of resources and information that if you're interested in a particular technology, you can go deeper and understand. So on the technology predictions, like under the AI piece, there's a breakdown of, okay, what are some of the current challenges? What are some of the opportunities? What can businesses do to help advance it? What can individuals do in terms of research to help advance the technology? Like smart agriculture, where are the challenges? One of the big challenges is being able to connect all the different systems of data. So there's like a whole weather system, there's a whole, genealogy and botany system, and then there's a technology sensor measurement system. But they're all separate and they're not connected. So an area of research might be, how do you correlate? How do you connect them? In wearables and integrated medical devices, one of the big challenges is power and the ability to have, longer lasting or low power architectures. So an area of research might be low power systems or new power topologies, like how do I actually do power regulation across, different grid networks, or in this case, different battery configurations or capabilities. So I would encourage, if anybody's interested, to go and look a little bit more at the websites to say, what are some of the opportunities or areas of research that might go into some of these technologies? And there's some ideas on the website.
Thanks, Ms. Nita. I think there's a question actually. Like the question is, a lot of people talk about AI and generative AI, the buzzwords. So what do you predict, like for the next 10 to 20 years? What can be the best one so that we can able to get some good job opportunities?
Yeah, so definitely understanding the use cases and the limitations. So one of the challenges with AI is that people think it's truly human, and it's not. It's just a very complicated set of rules, and this is why and frameworks and models. And so what I would encourage for people to think about is, depending on if you want to be a software engineer or if you want to be application design engineer, those are two different types of positions. And at the detail software engineer, understanding how you can leverage AI and generative AI to enable you to do work better and faster. And I think about this like from a lot of things that have happened in the mechanical and electrical space, and even in the software space. So, early days of software where everything was on an embedded system or a microcontroller or microprocessor, you actually had to understand like which register am I in and how am I moving, bits and bytes from register A to register B, and what does that look like? And now when you do software coding, you're doing it at a abstracted level. So when you're writing, Java or C or Ruby or whatever, or C#, you're doing it at a almost an abstracted language level. The LLMs will give you even further abstraction and allow you to think in more theory and logic terms without having to know the syntax. So as a software engineer, you should start to learn okay, what is the true logic that I'm trying to understand versus the actual syntax of like writing an if-then statement? Do I put the semicolon here or do I put the open bracket here? You don't have to worry as much with the generative AI because if you understand, I want to do a comparison, then you can have the AI generate the code for you for the language appropriate, like HTML or C# or whatever. But again, you have to understand the logic and you have to understand, does it make sense when it gives you an answer? So you have to know enough. So in that sense, I would suggest to people, focus on the thinking part of it versus the tactical part. And, language of programming is very tactical. Each one has its syntax, but with generative AI, you don't have to be as knowledgeable about the syntax anymore. You have to understand the language. If you're not a software programmer, but in general engineering or use of engineering, use Gen AI like a tool, like other tools, like for mechanical engineering, you have AutoCAD or Creo or NX or SolidWorks. It lets you do concept and creation without understanding or knowing the details of like fabrication for the part. So as a user, you can design new circuit boards and things as long as you understand the concept. So I guess the key takeaway is abstract to the higher order language, the higher order logic and the higher order architecture, because now you have tools that give you that low level or tactical implementation specific.
Yeah. Thank you so much, Ms. Nita. So it was a very clear understanding of it. So I think with this, as a token of gratitude on behalf of the Symbiosis of Technology Hyderabad, we really thank you so much for giving your time as well as giving the talk at the SITH Resist Talk series. We are very much glad and honored to have you on this. Please accept this token of appreciation from our side.
Yes, thank you very much. Thank you.
Thank you, Mr. Tan. Thank you. So participants, we have shared already a group link with you for the feedback. We'll be happy to listen your talk, your feedback. And this recording, we're actually trying to even get it uploaded on the YouTube channel, and we'll definitely sharing you the links so that you can able to use it for your future reference also. With this, on 11th, we are going to have a talk by Professor Asina, who is the distinguished lecturer of the IEEE Communication Society and also the Institute Research Fellow at Pakistan. So we're talking about the physical layer security in 6G from the theory to practice. So we'll all wait to hear from you all on the same topic. So thank you so much. Thank you so much, Nita. Have a great day.